Hi everyone, welcome to my channel Ravi Babu Edu Tech. Today we are going to cover full wave rectifier in VDC value. So that is the average or DC load voltage. That is what we are going to find out VDC. Now before we had already discussed in the VRMS value, that is VRMS is equal to Vm by root 2. So that was seen in the previous video. Now today we are going to looking VDC value, that is output DC load voltage. That is what VDC, and 1 by pi integral 0 to pi V into d omega t. So this is my expression. But why I am considering only 0 to pi? See here. So this is the input signal, and during positive half cycle you may getting this wave, and during negative half cycle you may getting this wave. So like that D1 D2, which is rectified continuous output. Okay, that's why we are taken only from 0 to pi, not required pi to 2 pi, because all are going same wave. That's why we are taking as only 0 to pi. That's what this is the expression. Yeah, so now let's start about derivative part. So VDC is equal to 1 by pi integral 0 to pi. What is V? V is nothing but input applied voltage, that is Vm sin omega t into d omega t. So that equal to, so this V get into the outside, that is Vm by pi integral 0 to pi sin omega t d omega t. That equal to Vm by pi. Now integration sign, as you know very well about integration part. So integration sign is nothing but minus cos omega t, that is 0 to pi. Okay, now Vm by pi. So minus of upper, you have to apply upper limit minus lower limit, that is cos pi minus cos 0. Okay, that equal to Vm by pi. So minus of what is cos pi? That is minus 1, and cos 0 also 1. So that equal to Vm by pi. So minus 1, that is minus 2. So that equal to Vm by pi. So that is minus to minus plus, that is 2. That equal to 2 Vm by pi. So this is the expression for VDC. Okay, so with help of these two values we have to calculate in terms of current IRMS value as well as IDC value. So hope you understand this derivative part. So let's calculate. IDC, that is DC load current. Now generally IDC is equal to what? As you know very well, according to Ohm's law, I equal to V by R. Okay, now at the load resistance RL, and here current, that is IDC, the drop across here VDC. So according that IDC is equal to VDC by RL. That equal to what is VDC? Just now we have seen 2 Vm by pi into 1 by RL. Okay, so finally IDC is equal to 2 Vm by pi RL. So this is for DC load current. DC load current. Okay, now let's calculate RMS value of the current. RMS value of the current, that means IRMS. Now before we had calculated IDC value, that is 2 Vm by pi RL. Now let's calculate IRMS, that equal to, even according to Ohm's law, that is what IRMS is nothing but VRMS by RL. Okay, now look at here, I equal to what? V by R. That is IM maximum current equal to maximum voltage by RL. So this can be written as RL equal to VM by IM. Okay, now this expression we are going to replace in place of RL. That is IRMS equal to VRMS divided by VM by IM. So that equal to, what is VRMS value? Already we had calculated in previous video. That is VM by root 2 in full wave rectifier. So now divided by VM by IM. Okay, now here VM get cancelled. This IM get into the numerator. That is IM by this root 2. That is what? IRMS. Okay, so this is the expression for RMS value of the current. Up to now, what are the values we had calculated? VRMS that equal to VM by root 2. That is IRMS that equal to IM by root 2. Then IDC 2VM by pi. So this is the expression, that is pi RL, and then VDC that equal to 2VM by pi. So these are the expressions. Now with help of this expression we will calculate about rectifier efficiency as well as ripple factor. Okay, so let's see these topics in the next video. Thank you for watching.